Expressing a function as a composition of two functions. Now that we have the vocabulary of function composition, we can use it as a tool to better understand what's going on in a complicated expression. As an example, consider the function r of x equals the square root of 3x squared plus 5. This, you'll recognize quickly, is a radical function, and it's fairly complicated as radical functions goes. Now, there are several ways that you could approach the problem from here, but what jumps out to me right away is that we are looking at a radical, and we're looking at some complicated stuff going on inside the radical. Both of those ideas are complicated. And it might be useful to separate those ideas out and think about them separately, right? The radical itself, square root of a number, and the stuff underneath the radical, 3x squared plus 5. You'll notice here that if I took f composed with g operating on x, that's going to be the square root of g of x, which is the square root of 3x squared plus 5, which is exactly what r of x originally was. So the idea here is when you have a very complicated function, see if you can break it up into a couple of different pieces and look at each piece separately. This is one way to deal with this particular composition. I can think of at least two others that will work for the function r of x that might be interesting. But instead of continuing there, I want to look at one more example. Here I have the function q of x equals 3 over 4x minus 7. This time we have a rational function. We have some fraction going on, and the denominator of the fraction is kind of messy. So, because of that, I might look at this as two separate ideas and try to break it apart. Again, the fraction thing going on, so let's look at f of x as 3 over x, right? Just get rid of all the complication going on in the denominator because just having a fraction is complicated enough. But we can't just get rid of it, so we take all that complicated stuff and we name it as something else, in this case g of x. And if we wanted to look at f composed with g, we can double check ourselves and realize that this is going to be 3 over g of x. And when we substitute in the value of g of x, we get 3 over 4x minus 7. And 3 over 4x minus 7 is exactly what q of x was to start. Looking forward, most of you taking this course are going to move onward to a calculus course in your future. And in calculus, being able to analyze a function like this, breaking it into its individual components, will turn a lot of problems from something that makes you want to completely tear your hair out into a couple of fairly straightforward steps.